Okay. February, March 2022, paper 3, variant 2. Question 1. An elastic band, some masses. The total mass of the masses and the mass hanger is 300 grams. Calculate the total weight. How can,
كمان
how,
سؤال،
hmm,
احنا بنحول الجرامز لكيلو جرامز ولا بنسيبها كده على طول؟
yes. To find the weight, we must use kilograms, صح?
اوكي.
We must use kilograms. طيب, how can we convert from grams to kilograms?
divide 1000.
300 divided by 1000, 0.3 kilograms. Then weight equals
0.3 times 9.8.
weight equals mg 0.3 times 9.8, which is total weight
انا مش معايا كالكوليت.
طيب times 9.8 2.94 newtons. 2.94 newtons. Okay, and next question. The student uses a stopwatch to time 20 oscillations. Figure 1.2 shows the time reading on the stopwatch after the 20th oscillation. Determine the time in seconds for the 20 oscillations.
66.4.
Okay. 1 times 60 would be 60 plus 6.4, which would be 66.4 seconds. Calculate the time in seconds for one oscillation
6.4 over 20.
over 20. Okay. Which would be
تبقى 3.32.
okay, 3.32 seconds. Yeah. When the student pulls the mass hanger down, energy is stored in the elastic band as elastic potential energy. Describe what happens to this energy stored when the student releases the mass hanger and it moves upwards.
نقول هتبقى من elastic
Okay.
potential هتبقى gravitational.
Okay. Okay. It will become gravitational or what happens to the elastic potential energy initially? What happens to this elastic potential energy?
increase.
لا, it
لا decrease.
decreases. Elastic potential energy decreases. And as it moves upwards, gravitational potential energy increases. You can also say that the kinetic energy increases as well. Kinetic energy increases as well. Okay. Yeah, moving on. The pivot in the shoulder is 0.9 meters from the center of the mass of the weight. Calculate the moment. How can I find the moment?
Force times distance.
Yeah, force times perpendicular distance. Moment equals force times perpendicular distance, which is what's
50 times
huh,
0.9.
50 times 0.9,
45.
45 Newton meters. Okay, quite easy. Student does some running exercises, speed time graph. Describe the motion in AB and AB acceleration. What does acceleration mean?
Increasing the speed.
Increasing the speed, huh? Oh, speed increases or acceleration. Okay. Well, speed increases, or you can say acceleration. What about section DE?
Stop.
Stops at rest, correct? Okay, good. Calculate the distance moved by the athlete from time 0 to time 5 seconds. This
area under the graph half times base times height
Mhm. Yeah.
فده
Area
half times 5 times 8
area under the graph, which is a triangle, half times base times height. Base is 5 and the height is 8. Yes, half
فده
times
10
20 meters. Calculate the volume of the block.
نعمل 12 times 2 times 2
Length times width times height.
48
12 times 2 times 2, 48 centimeters cubed. A different metal block has a mass of 86 grams, a volume of 8 centimeters. Calculate the density. Okay, density equals mass over volume.
86 over 8
Okay,
تبقى 10.7 10.8
okay, 10.8.
عمال بتكلم كل ده وانا عامل عامل ميوت.
Newt. 10.8 grams per centimeters cubed. The metal block is placed in some liquid. It floats. Suggest a value for the density of the liquid.
هتبقى مثلا لو يعني ميتال
12
بلوك فلوتس هتبقى المفروض الليكويد
12
اكتر.
Yes, okay. 12,
12
13, 14, whatever. Any number which is above 10.8. A student has a measuring cylinder, a beaker of liquid, and a balance. Describe how the student can use the equipment to determine the density of this liquid. How can I find the density? Hmm. How can he find the density of this liquid? First of all, what should he do?
مش عارفة عمري ما خليت سؤال كده
Hmm. It's a very easy question. Density of the liquid. Now we need what? We need the mass and the volume of the liquid.
اه
The volume of the liquid is
لو
easy. We can
عرفت
find the volume from the measuring cylinder. How can we find the mass of the liquid? Huh.
بالبالانس
ماشي. اول حاجه هنجيب الليكويد مثلا، هنحط الميجرنج سيلندر الاول على بالانس،
Hmm?
بعدين نحط الليكويد في الميجرنج سيلندر جوه البالانس.
يبقى
او لا
first of all,
بعدين
hmm,
بعدين
find
هنعمل بقى هنعمل
uh,
we're gonna find the volume الأول
find the mass of the empty cylinder. Okay, the empty measuring cylinder. Okay,
بعدين هنحط ليكويد فيها.
M1. بالظبط. Add some liquid to the measuring cylinder. Add liquid to the measuring cylinder. I'll just write it as MC. But in the exam, do not write MC. Just write it as measuring cylinder. And measure the mass, okay? And find the new mass, M2. Um, the mass of the liquid alone, okay, the mass of the liquid alone would be equal to M equals M2 minus M1, which is the mass of the measuring cylinder, and the liquid minus the mass of the measuring cylinder. Then find the volume from the measuring cylinder. Find the volume from the measuring cylinder. V, and then calculate density. Okay, density equals mass over volume. Okay, quite easy. Okay, yeah. Next question. Coal-fired power stations provide electricity for homes and industry. A government decides to replace coal-fired power station with a hydroelectric power station. Describe how electrical energy may be obtained from the gravitational potential energy of the water behind the hydroelectric dam. how can we obtain electricity? Any ideas? Seems like you have forgotten. We have a dam and we have some water behind the dam. This water rises to a certain level and the gravitational potential energy of this water increases. Then what happens? Water passes, hmm, the water passes through a pipe. Okay, a pipe, converting the gravitational potential energy to kinetic energy. Now it's moving quite fast and inside this pipe, converting this gravitational potential energy to kinetic energy, thus rotating a turbine. When this turbine rotates, okay, which also rotates a generator. Okay, the turbine is attached to a generator. This generator starts to rotate. Okay, converting the kinetic energy to electrical energy. That's it. Please do not write down any abbreviations. Write down kinetic energy. Do not write down KE. And don't write down GPE, gravitational potential energy. Apart from the cost, state two advantages of generating electricity using a hydroelectric power station.
renewable.
Okay, renewable.
Uh,
It is renewable. What else?
فكرة تانية.
branch pollution.
What type of pollution?
air pollution.
air pollution.
Okay. برضو يعني not just air pollution, okay? You have many different types of air pollution. You can say it doesn't, for example, it doesn't contribute to greenhouse effects, for example. It doesn't contribute or it doesn't produce any acid rain. It doesn't produce any carbon dioxide pollution, okay? Don't just say air pollution. Air pollution is a very vague word. Okay, no, for example, no carbon dioxide pollution. For example, okay. Apart from the cost, state two disadvantages of generating electricity using hydroelectric power station compared with the coal-fired power station.
needs more space.
Okay, takes up more space. ماشي. Hmm. What else?
هو قال ما ينفعش cost.
Hmm.
انا عارفة اللي هو بيموتوا اللي هو البيردز وكده.
Okay, it does damage the wildlife, for example. Okay.
حضرتك عارف ده أوحش سؤال في
لا, it's quite easy, بس هو it's more of a theoretical question, and that's why we sometimes forget the answers. Yeah, moving on. Determine the resultant force. Resultant force would be
20 - 90 تبقى 30 to
30
the left.
to the left. The weight, the total weight in the boxes is 900 newtons. The area of each wheel is 8 centimeters. The trolley has 4 wheels. Calculate the pressure and include the unit.
ماشي. pressure equals force over area.
Okay.
عشان نجيب الآية هنعمل 8 times 4.
Okay, so the total area is 8 times 4, 32 centimeters squared.
وبعدها special
هتبقى
force هيبقى
900 divided
32,
32.
yes. Uh-huh. What's the final answer?
تبقى 28.1.
28.1. What's the unit?
Newton per centimeter
إنه
square.
سنتيمتر سكوير.
Newton per centimeter squared. Okay, good. Describe the motion of the gas particles.
Move fast and freely.
Fast and random in all directions. Okay. Fast and random in all. Okay. State how the motion of the gas particles changes when the gas container is cooled.
slow.
Particles get close together أو slide past each other.
لا انت you said slower, right?
ايوه
Slower طبعا. Slower motion. The motion, I'm talking about this motion. I didn't talk about the spaces between them. The motion gets slower because they lose kinetic energy. Okay. How do the gas particles exert pressure on the walls?
by collisions.
Side of the container wall.
Collisions. But when you say collisions, you have to say collisions with the walls. Okay. Gas particles. Okay. Collide with the walls, exerting a force. Okay, exerting a force over an area. And force over area, it is pressure. Which is pressure. Okay. State the name for the transfer of thermal energy through metal. What's the transfer of of thermal energy through a metal? Conduction. Describe how thermal energy causes the movement of the water shown.
When it is applied مش عارفة.
What's the name of this process?
Conduction.
Convection. This process is called convection. What happens in convection? Whenever the water gets heated, okay, water gains kinetic energy. It expands, okay. Volume increases. As the volume increases, the density decreases. When the density decreases, what happens? The hot water rises up and the cold water falls down. Assume places equal masses.
ثانية عشان
Okay. Assume places equal masses of water into two metal cans. The cans are identical apart from one having a white outer surface and the other one having a black outer surface. The student places the two cans in direct sunlight. State and explain which can has the greater increase in temperature. It's quite obvious. Which can has the greater increase in temperature? White one or the black one?
which one
Has the greater increase in temperature?
the black one.
Black outer surface. Only black outer surface. Why? Hmm.
عشان البلاك هو اللي بيأتراكت السن.
You can't say attract. There is a specific keyword we need to say.
conduct.
No. Black is always the best absorber of best absorber of infrared radiation. Can't say it's the best conductor. No, you can't say it's the best emitter. No, it has to be, in this case, it has to be the best what? The best absorber of infrared radiation.
Okay.
Draw on figure 8.1 to indicate the amplitude and label it A. Amplitude would be
اللي هو من زيرو طالعين لفوق.
okay. This is the amplitude A. One wavelength.
للجنب.
Okay. From one crest to one crest, or from one wave, from one trough to one trough. Soon creates waves in water tank and places various barriers. And figure 8.2 shows the wavefronts as they approach the barrier at an angle of 45 degrees to the wavefronts. Draw 3 wavefronts after they have reflected from the barrier. Draw an arrow to show the direction of the of travel of these wavefronts. Okay, good. We need to see 3 wavefronts after they have reflected. First of all, direction. We need to continue the direction. Okay, you need to continue this direction using your ruler all the way until it reaches the barrier. Okay.
كان نعملها لتحت.
Okay. Yeah. This is the first thing. At this point, you need to draw a normal. At this point, you have to draw a normal. Make sure that the angle with the normal is 45 degrees. Make sure that the angle with the normal is 45 degrees. Why? Because the angle of incidence has to be equal to the angle of reflection. Therefore, the angle of reflection, it will reflect downwards. It will reflect vertically downwards. Okay. This is the direction of the wave now, which has an angle of 45 degrees now. Okay, am I done? No, I'm not done yet. Why? Because I have to draw 3 wavefronts. What did I draw? What's this thing that I drew? This is just the direction. It's the direction of the motion of the wave. That's why I drew an arrow facing downwards. Where are the wavefronts? How can I draw the wavefronts now? The wavefronts have to be perpendicular to this direction of motion. What do I mean? I have to draw 3 waves or 3 wavefronts which are perpendicular and have the same distance between them. So you need to measure the distance, the initial distance, which is the wavelength. You need to measure the wavelength using a ruler, of course, and then you need to draw 3 waves, 3 wavefronts, which have the same distance between them. Okay, in this manner. You have to make sure that these waves are the same distance. How long are they? It doesn't matter. They could be short, they could be long, it doesn't matter. What matters is the distance between them, okay? And that they have to be perpendicular to this line, to this blue line, which is the direction of the waves. The direction of the waves is now downwards, okay? The distance between them, I guess, was maybe 1 centimeter or something. I don't remember. But you have to make sure that the distance between them is equal and that they are perpendicular to the line which is facing downwards. That's it. So this is the direction of the reflected wave fronts. Okay. We don't have too many questions like this one. It's a rather harder question, one of the harder questions in our syllabus, but we need to do it. Okay, you need to make sure that you know how to do it. Okay. Okay. Now the student replaces the barrier with a different barrier. This barrier has a narrow gap. Whenever I have a narrow gap, what will happen? What's the name of the process that will happen now? Yeah.
تاني كده.
What's the name of the process that will happen as the wavefronts pass through this narrow gap? Hmm.
هيصغروا.
What's the name of the process? Hmm. The process is named diffraction. Okay. How will the waves diffract? Using a compass, we need to draw 3 wavefronts after they have passed. We need to draw using a compass type. What should I do? I'll use the compass. I will put the pointy edge in the center of the narrow gap. I'll put the pointy edge in the center of the narrow gap. And then I will open up the compass to the first wave. Do not draw this. Don't draw this. Just open up the compass to the first wave, this way. And then using this same opening, draw a semicircle on the opposite side. While the compass is still centered in the middle of the gap, centered, draw a wave, draw a semicircular wave on the opposite side. And then again, using your same compass, while it's still centered here, in the narrow gap, open it up to the second gap. I'll open it up to the second wavefront. I'll open it up to the second wavefront. And then again, I will rotate the compass and draw a semicircle on the opposite side. This way, okay? Of course, your waves should be a lot more accurate than mine. And then still, while your compass is still centered here, open it up to the third wavefront. And then rotate the compass and draw a semicircle on the opposite side كده. So now we have 3 wavefronts. Should you draw the fourth one? No, only draw 3 wavefronts. He was very specific. Draw 3 wavefronts, then you must draw 3 wavefronts. That's it. Now I drew 3 wavefronts. This is your final answer. It should be like this. Okay.
والسؤال ده ما بيجيش غير في paper 3 بس، صح؟
Only paper 3, yes. Only 3 wavefronts. Yeah. An easier question. State the name of the unlabeled region.
Microwaves.
Microwaves. Direction of the arrow shows the region of electromagnetic spectrum in order of increasing what?
frequency.
Frequency. State 2 uses for X-rays.
check for broken bone.
Okay. Checking for broken bones. What else?
ولا
وفي
check.
المطار دي.
Broken bones
security checks.
and security checks. Okay. Why X-rays can be harmful to people? Why can they be harmful?
عشان عندها high frequency.
High frequency. Okay, what does this high frequency do? It's the same as gamma rays. They damage. hmm, They damage the healthy cells. They cause mutation. They cause cancer. They cause damage to the DNA. They damage healthy human cells. They could cause cancer. Okay, they could cause mutation. Okay. Student wants to determine the resistance of the LDR. Draw on figure 10.1 to show how he will connect the voltmeter. Okay, this is quite easy. You can draw the voltmeter, okay, below or above the LDR. The current in the LDR is 0.02 amperes when the potential difference is 5.4 volts. Calculate the resistance. R equals
V over I.
V
Yep.
5.4 over 0.02, which is
270.
270 ohms. Okay. When the student shines a light onto the LDR, its resistance is 150 ohms. The resistance of the variable resistor is 180 ohms. Determine the combined resistance of the LDR and the variable resistor.
330.
Okay, 150 plus 180 is 330 ohms. Okay. Transformer VP 240, NP 590, NS 48. Can I find VS? It's a very straightforward question. What's the equation we will use?
NS over NP equals VS over VP.
Okay. يعني
هي أي
NS
حاجة.
over MP equals VS over VP. Okay. I personally I prefer VP over NP equals VS over NS. It's the same. It's the same equation. You can it will give you the same final answer. Okay, let's use the NS over NP VS over VP. NS is
48.
48 and NP is
509.
590. VS, I don't know it. VP is
240.
simple cross multiplication.
240 times 48 over 590
Mm-hmm.
تبقى 19.5.
Okay, 19.5. Describe how a fuse works.
مش فاكرة قوي بس اللي هو
the
لما
current increases
temperature
يعني أو
it melts.
It
melts
melts.
بالظبط to stop explosion ولا أي حاجة.
Fuse melts when the current increases to protect the device from overheating. Yeah, easy. What's the nature of a beta?
Ionizing.
Nature of the beta. يعني الجاما was electromagnetic wave. الالpha was a helium nucleus. What's the beta? It's an electron. What's the relative charge of an alpha?
+1.
+2. Relative charge of an alpha is +2. What's the ionizing ability of an alpha?
Right.
Okay, high or strong. Okay. Which type of radiation is the most penetrating? Most
أظن
penetrating.
الجاما.
Gamma, of course. This is a beryllium isotope. State the names for X and Y.
أول واحدة بروتون والتانية
Okay. X has to be protons. Why? Because we have 4 protons. So we have 4. Hmm. And of course, Y is the neutrons.